You have built an amazing prototype with Claude. It works perfectly in testing. Then you launch, and everything falls apart at 50 concurrent users. Today, I am showing you the exact production-ready architecture I have used to deploy multiple AI applications that scale smoothly to thousands of users. Most tutorials are wrong. I skipped straight to profitable apps. Here's how. So you built your first Claude app, and it worked perfectly for a dozen users. But now you have hundreds, and it's collapsing. Why? Because every single user request triggers a direct, immediate call to the Claude API. What this means is the entire system grinds to a halt, waiting on each individual response. That's the synchronous trap that instantly cripples scalability. And it gets worse. You are burning tokens on every single request without control. The key insight is this: direct, unstructured API access means even small, simple queries are expensive. What happens when those costs multiply by 1,000? A single poorly optimized prompt can now sink your entire budget overnight. And you are left completely powerless to stop it. The system just fails, and you have no clear record of why. Was it a bad user input? A sudden API change? You cannot improve what you cannot measure. You are flying blind into production chaos, with no visibility into performance bottlenecks or where your resources are actually going. Think about building a house without any memory of which walls you put up or rooms you left unfinished. That's your stateless app. Every user interaction becomes a brand new construction site, forcing Claude to start from scratch each time. This destroys all context and continuity, making meaningful conversations impossible under any real load. Most AI apps fail. Here's why Claude is your unfair advantage. Hold on. You think your sync endpoint can survive a sudden flood of traffic? It cannot. The pattern clearly indicates that user requests will back up and crash everything. Here's what's really happening: your first layer must be async. It instantly accepts requests, queues them, and gracefully handles timeouts before they ever hit your core logic. This is your traffic shock absorber. Think about that initial shock of high demand. The key insight is that this layer does not process requests, it manages chaos. What this means is that you are deciding which work matters most, right at the gate, preventing critical tasks from getting buried in the noise. You are building in resilience before a single line of your AI logic runs. This is your execution engine. What this means is that this layer isn't just about sending prompts. It is about implementing intelligent retry logic when an API call fails, and it's about having a predefined fallback model ready. You are guaranteeing a response, even if your primary AI service has an unexpected issue. Think of this as your application's long-term memory. It's not just a simple log. The system takes every user conversation, structures the core data, and creates a searchable vector index. This allows your AI to instantly recall past context and user preferences, making every future interaction far more personal and relevant. Stop building toy projects. I ship real AI apps that make money. Forget single, fragile prompts. Production demands intelligent templates that dynamically assemble from user input and persistent context. This is how your application remembers conversations and maintains consistency across thousands of sessions. You are not just making calls, you are engineering a reliable state machine for your AI, a cornerstone of any serious, scalable system. But here's the trap. Static prompts waste tokens and money. You must allocate intelligence strategically. A premium user's complex query gets a larger budget, a simple lookup gets the minimum. This isn't a fixed setting, it's a real-time calculation, optimizing cost against the value of each response. Fail at this, and your margins vanish under unpredictable load. Now, your response is your product. You cannot return a failure, an error, or dangerous content. The final step is a dedicated pipeline that validates every output for safety and structure, then sanitizes it for the user. Without this, one unpredictable response can break trust or your entire application. So your prompts improve over time. But you cannot guess. You must know. A controlled, measurable pipeline pits prompt variations against each other, tracking real performance. This isn't opinion, it is data. The winning version gets deployed, continuously optimizing your application's intelligence based on actual user interaction. Most devs get AI wrong. Here's the framework that actually builds profitable apps. Here's a massive, hidden lever for profitability. By batching multiple user queries into a single request to Claude, you are not just saving money, you are fundamentally redesigning your system's economics. This consolidation dramatically increases your token efficiency, turning sporadic, expensive calls into a single, powerful transaction. It is the difference between paying retail and wholesale for intelligence. Think beyond just the API. The real game changer is implementing a layered caching strategy right within your application. Store both frequent user questions and your AI's complex reasoning steps. This eliminates redundant processing entirely, slashing costs and boosting response speeds simultaneously. You are not just calling an API, you are building an intelligent, self-optimizing system. But everyone gets rate limiting wrong. It is not just blocking users, it is about intelligent prioritization. When capacity tightens, premium features degrade first for free users, while core functionality stays alive. This means your system self-regulates under load, protecting revenue without a single support ticket. You control costs by design, not by emergency. Think of a surgeon in a busy operating room. The vital monitor shows you everything: pulse, cost, rate limit, health. The moment it dips, alarms sound, but the core procedure continues uninterrupted. You are not just watching expenses, you are managing system vitals in real time. That analysis becomes your command center, letting you prioritize life support over everything else. While tutorials fail, 3 profitable AI apps do not. Here's how. But here's the hidden truth. Average latency will mislead you completely. The key insight is to track the 95th and 99th percentiles, especially under heavy, varied prompts. What this means is you catch the outliers that break user trust. The pattern clearly indicates that controlling these worst-case responses is what separates a professional system from a failing prototype. But when you monitor errors, you have to move beyond just counting failures. The key insight is to categorize errors by root cause, server overload, timeouts, content violations. What this means is you stop blindly retrying doomed requests, preserve your budget, and identify system weaknesses that truly need your immediate engineering attention. Now, With that in place, you must also track efficiency. The pattern clearly indicates which features drain your budget. Here's what's really happening. You'll see if a premium user segment costs 10 times more than others, allowing you to optimize prompts or adjust pricing before your margins silently disappear. This is where you proactively catch mistakes. The key insight is that subtle changes in your prompts can quietly degrade performance or inflate costs. What this means is you need automated alerts that trigger the moment your AI's quality or efficiency slips, allowing you to revert a bad change before real users are ever affected. While everyone's tinkering, I am shipping profitable AI apps. Here's how. But shipping in a container is just a box. The real power comes from teaching it to signal. When your app integrates automatic health checks, your entire system can self-heal. The moment a component falters, it gets flagged, restarted, or replaced seamlessly. This is the resilience that keeps real users happy, no matter the load. This is where your system starts to think. The insight? It does not just watch resources. It reads intent by tracking the backlog of user requests and their wait times. The moment the queue deepens or responses slow, it autonomously spins up new instances. Your architecture now scales with actual demand, not guesswork, guaranteeing performance under real traffic. But you must update it. The problem? Downtime. The blue-green pattern solves this by running two identical environments. You deploy to idle green, test thoroughly, then switch user traffic instantly. If anything fails, you roll back to stable blue with a single command. The result? Your users never see an update, just uninterrupted service. The key insight is that your Claude API can still fail. A true disaster recovery plan does not just have a backup system, it predefines your exact response. It documents immediate fallback logic, escalation triggers, and a full communication protocol, so when an outage hits, your team executes a known plan, not a panic. Your application's resilience is defined by its weakest prepared moment. Scalable Claude apps require layered architecture, not just API calls. Production success depends on monitoring, caching, and rate limiting. The right patterns let you scale costs predictably with user growth. Pick one scaling challenge from your current project and apply one pattern from this video.